Hello, I'm Eralp Kumbasar. I will present you my EE 102 digital design project. I made an auto car assistance system using Basis tree, and the car can stop when it sees an obstacle when moving forward and also backward. And according to the choice of the driver, it can also turn left or right when it sees an obstacle. I control the car using the switches of Basis tree. This switch opens the car assistance system. The fifth switch simply turns on the power. If I start moving the car without opening the switch, it will move on regardless of the obstacles. This switch will allow it to stop when it sees the obstacle. The second switch is to decide whether the car will move forward or backward. When the switch is on, the car will move backwards. And the third switch decides whether or not the car will turn left when it sees an obstacle. If it's on, the car will turn left when it sees an obstacle. When it is too close, when the obstacle is too close, it will stop as it does when this is closed. And the fourth one is for turning the car to the right. So now our system is open, and when I turn the power on, the car will start moving, and it will stop when it sees the obstacle. In a similar way, it will also stop. As you saw, when I started the system, it didn't care about the obstacle and it moved forward. So now we will observe the reverse movement. This part is the back part of the car, and when I start the car moving in the reverse direction, the car will stop when it sees the obstacle, in the same way it does in the forward case. As you can see, the car stopped when it was moving backwards. And when you look closer, the buzzer here is giving sound. This buzzer is to warn the driver regarding the possibility of hitting an obstacle from behind. It has 4 cases for different distances, and I use the clock divider to define this property. So now we will observe the turning to left function. The car will turn left when it sees the obstacle, and it will probably turn left again there when it sees the table there. Let's see now. As you can see, when the obstacle is too close, like my hand, it stops. When it stops, this light is on to warn the driver is behind. Also, we couldn't see it in close since the camera was too far. But when the car is turning to left or right, you can see this LED turning on and off. This is to give a signal, as in the real cars, in order to warn the car is coming from behind. In the same way that it turns left, the car will also turn right. You will see this motion. Now, the car again stops when it sees an obstacle too close. The car can also turn left or right when it sees an obstacle from behind. With this project, I aim to propose a solution for the severity and the rates of car accidents. I wanted to decrease the rates of the car accidents. If the car stops when it sees an obstacle, it will be harder for the car to hit the car that is moving in front. And if the car turns left or right, it will not interrupt the flow of traffic. So the possibility of another car hitting this car from behind when it stops because of an obstacle will be removed. So in order to do this, I used 4 motors. Four motors which are driven by one motor driver. I used 1 LED. The other 3 LEDs are not lighted because of voltage problems. So I put these LEDs, which are turning to left, turning to right, and reverse signal to basis tree, as I have demonstrated before. And there's a buzzer which warns the driver about the distance of the obstacle that is enclosed from behind. And I use two distance sensors, which I programmed in basis tree in order to get the data. And I programmed the LEDs here by clock dividers and the buzzer in order to get a signal with different frequencies. Thank you for listening to me.